All right, so what if you had to make a life-changing choice right now, but you had to do it at the exact same time as someone else, with absolutely no idea what they were going to do? That's the heart of what's called a simultaneous game. And today, we're diving into the most famous and frankly the most mind-bending example of it all, the prisoner's dilemma.
Okay, I want you to really put yourself in this situation. You and a partner in crime. You've been caught. You're sitting in two separate, cold interrogation rooms. There's no way to talk, no secret signals. A prosecutor walks in, slides a folder across the table, and offers you, and only you, a deal. Your entire future now hangs on what you decide, and on what your partner is deciding in the other room, right this very second.
So let's break down this classic scenario. It's all about trust and betrayal, and we're going to pick it apart piece by piece to really get a handle on the fascinating and often counterintuitive logic that kicks in when we're forced to make a choice completely in the dark.
Here's the deal the prosecutor lays out for you. It's simple, but the consequences are huge. Option 1, you rat out your partner, and they keep their mouth shut. If that happens, you walk away a free person. But if the tables are turned, if they rat you out and you stay loyal, you're the one taking the fall, big time. Now, if you both sing like canaries, you both do some time, but it's not the maximum sentence. And then there's the last option. If you both manage to stay silent, they can only pin a minor charge on you and you both get a slap on the wrist. The thing that makes this a complete strategic nightmare is that it's a simultaneous game. Now, that doesn't mean you have to decide in the same exact microsecond. It just means you have to act without knowing what the other player is doing. You are making your choice in a total information vacuum.
So this chart here is called a payoff matrix, and it's the perfect way to see all the possible outcomes at once. Let's walk through it. If you look at that top left box, that's where you both stay silent. You cooperate. The result? Just 1 year in prison each. Not bad. Now look at the bottom right. That's where you both confess. Mutual betrayal. You both get 2 years. But it's those other two boxes, the ones where one person talks and the other doesn't, that's where the real temptation and fear really start to mess with your head.
So what do? How do you figure this out? Well, we're going to put ourselves right in that prisoner's mindset and think through this with pure, cold logic. No emotions, just rational self-interest. Let's figure out the single best move you can make, no matter what. The best way to untangle a complex problem like this is to break it down into two simple what-if scenarios. First, you ask yourself, okay, let's just assume for a second my partner is going to stay loyal and keep their mouth shut. What should I do? Then you ask the opposite. Okay, what if my partner betrays me? What's my best move then? If we look at both, the best path should pop right out. Okay, scenario 1. Let's pretend your partner is a true friend and is staying silent. So what are your options? You can stay silent too and you'll get 1 year in prison. Or you can confess and you get 0 years. You walk free. I mean, 0 is obviously better than 1, right? So if your partner stays silent, your best move is to confess. All right, now for scenario 2. Let's assume the worst. Your partner cracks under the pressure and confesses. Now what? Well, if you stay silent, you're looking at 5 long years behind bars. But if you also confess, you only get 2 years. 2 years is way better than 5. So get this, even if your partner confesses, your best move is still to confess. Did you see what just happened? No matter what your partner does, whether they stay silent or confess, your best move is always the same. And that is what game theorists call a dominant strategy. It's the move that gives you the best personal outcome, period, regardless of what anyone else does. It's the no-brainer choice. And here's the kicker. Since confessing is always better for you, it's your dominant strategy. But remember, the game is perfectly symmetrical. Your partner is in the other room, thinking through the exact same logic, which means confessing is their dominant strategy too. So two perfectly rational people, thinking independently, are both going to arrive at the exact same conclusion. I have to confess. So, you both do the smart thing. You both play your dominant strategy. You both confess. And this is where the dilemma gets its name. This is where it gets truly weird. Because when both of you act perfectly rationally to help yourselves, the outcome is, well, it's actually pretty bad for both of you.
Just look at this comparison. The rational choice, where you both confess, lands you both in prison for 2 years. This outcome is called a Nash equilibrium, which basically means you're at a point where neither of you can improve your situation by changing your mind alone. But here's the paradox.
If you had both made the irrational choice and stayed silent, you would have only served 1 year each. It's an outcome that is clearly better for both of you, but you can't reach it through pure self-interest. You both lose by trying to win.
This quote really just nails it. It perfectly captures that central conflict between what's good for the individual and what's good for the group. Following your own best interest logically leads to a result that is worse for everyone involved.
Now, you might be sitting there thinking, okay, that's a cool thought experiment, but I'm not planning on getting arrested anytime soon. But here's the incredible thing. This exact same strategic puzzle, this tension, it shows up everywhere, from global politics to simple, everyday decisions.
Take this super simple example. Bill has a blue cap. Rose has a red one. Bill wants the red. Rose wants the blue. The best outcome for both of them is to just trade, right? They both get what they want. But look at the logic. If Bill offers his cap, Rose is tempted to just keep hers and walk away with both caps. And of course, the same logic applies to Bill. So the dominant strategy for both is to just hold on to what they've got, and no trade happens, even though they'd both be happier if they had just trusted each other.
And you see this dynamic everywhere. I mean, think about two gas stations on opposite corners. If one lowers its price, it gets a ton of new customers. So the other one is forced to lower its price too. Before you know it, they're in a price war, and both are making less money. It's the same with something huge like climate agreements. Every country's better off if we all cut emissions, but each individual country is tempted to cheat and let everyone else do the hard work. It's even in TV game shows and office politics when you're deciding whether to share the credit or try to take it all for yourself.
So, what's the big takeaway here? What does this all boil down to? At its very core, the prisoner's dilemma is a model for one of the most fundamental choices we face over and over again. Do we cooperate or do we compete?
What the prisoner's dilemma so brilliantly shows us is this deep, often unavoidable conflict between individual rationality and the collective good. It's a powerful reminder that simply following our own logical self-interest doesn't always lead to the best outcome, not for the group, and a lot of the time, not even for ourselves. And that leaves us with one last, really powerful question to think about. If cold, hard logic can so easily lead us to a worst outcome for everyone, what makes cooperation even possible? The answer has to lie in all the things this simple model leaves out. Things like reputation, the possibility of future interactions, and maybe the most human and sometimes irrational element of all, trust. So knowing all this, when is it truly rational to take that leap of faith?